Hey, PJ here. The question of the day is finding the linear equation for time and velocity relationships. We're given a table here of time and three values for time. 0, time is equal to 0, time is equal to 1, and time is equal to 2. And we're given three values for velocity. Velocity starts at 120 at time 0 and goes to 152 and it goes to 184. So I want to show you the fastest way to solve this and also the easiest way to, the fastest way to solve this, which is the easiest way, and then also the most rigorous way to solve this. So first, what we should notice in terms of the quick way to solve this is that t and v have some relationship where if t is 0, v is already 120. So part of what that means is that if we say v is equal to some constant times t, and we don't know if t is going to be squared or what the relationship is going to be in terms of if it's going to be linear or exponential at this point, we don't know. But what we can say is that at 0t, it's 120. So we should add 120 to this formula for v. And then what we might also notice is that this is a jump of 32. And this is a jump of 32 again, which means we have a linear relationship. It is increasing linearly by a factor of 32 for every t. And so this is the solution for our problem. Here is the more rigorous way of thinking about this. So let's say we have a graph of velocity and time, right? Where time is the x-axis. Time is the x-axis and velocity is our y-axis. So this is greater velocity, this is lower, this is time. And of course, we begin at time 0, but we don't start at 0 velocity. We start up here at 120 velocity. And then at time is equal to 1, we move up here to 152 velocity, right? And then at time is equal to 2, we move up linearly by the same amount to 184 velocity. So if we graph, we find this line and we can assume it keeps going. The slope of this line is going to be calculated by the slope equation, which will give us the y1, right? y2 minus y1. So we could assume that this is the y, right, of this. The x, of course, is 1 here. So the coordinate of this point would be 1 and 152 for x and y. And then we could just use this one. This can be our point number 2. So our y2 comes from it. And then this can be our point number 1. 0, 120, x and y, right? Time, velocity. So what we do is we do 152 minus 120, which is this, right? And the equation says that that has to be over x2 minus x1. Now, x1 is just 0, so it's just going to be over x2. So this is going to be over 1 because x2 is equal to 1 right here. Okay, we find that this is equal to 32, and that is the slope of our line. Notice that this is in y is equal to mx plus b form, where this is the x and this is the y. That's what we've described here, and that's the rigorous solution to this problem. Of course, the b term is wherever the line crosses the axis for y. In other words, if x is 0 or if time is 0, what is y? And we are just given that value. We are given 120. So we can plug that in and say that this formula must be v is equal to 32t plus 120, which is what we found intuitively to be true up here.